Hello, programming languages students. So for this video in grammars, we are going to talk about the basic grammar rule writing, basic grammar writing syntax. And we're going to start with a simple example here. And note, as I go through this, we're gonna have a couple of rules that we use. Capital letters will mean this is a rule definition with a capital letter, and lowercase letters will be terminal symbols. So these are things that our sentence ends with. Um, You'll notice if you think back to the first video, we looked at the Java grammar, and it used, if you actually look into it, it uses capital letters or maybe even lowercase, less than, greater than signs to designate rules. Um, but however you designate rules, it doesn't matter as long as there's a definition. So for all of our examples in this class, we're following the definition that rules are capital letters and terminals are lowercase letters. These definitions we'll talk about in a later video, but for us, that's what we will define. And for all of our grammars, we will define S, capital S, as the start symbol. So we're going to look at our first language. Let's just dive right in and see a set of two rules for a grammar. So the rules for the grammar are defined here. Capital S goes to lowercase a capital A or lambda, and capital A goes to B capital S. And so the way that you can really read and start to understand grammars is thinking about substitutions. So every sentence in our language starts with a capital S, and every capital letter is a rule, which means it must be substituted for one of its possible resolutions, one of its possible values that are associated with the rule. So real quickly, if we start with an S, and these are the S rules, would it be possible to create an empty string? Does this language, defined by these grammar rules, have an empty string in it? Well, hopefully your instinct is yes, because we could just substitute capital S with lambda, and so we're good to go. We're done. But to figure the rest of this out, let's think about, is the letter lowercase a possible with these rules? Well, for substitutions, you have to take a capital S and substitute for something. Well, obviously, if we substitute for lambda, we're done. There's nothing, no other rules, no other things to do, and there's no a, so that doesn't work. So if we choose the rule lowercase a capital A, then we get an a, and so maybe this is possible, but unfortunately for our capital A, there is no option for lambda. There's no or lambda here. So that means that we can only substitute our capital A with a lowercase b and an s. So we get lowercase a and then lowercase b and then an s. The s loops us back into this rule, and we can choose lambda there, but that doesn't get us the letter a. That does not get us an output of the letter a. So getting the letter a is not possible with these rules, but the process I just walked you through would get us to an AB, right? We substitute s with lowercase a, capital A. We substitute capital A with b, lowercase b, capital S, and we substitute our capital S with a lambda, and we have AB. And so AB is possible. Would AB be possible? Well, by repeating this loop one more time, by choosing after we get an AB to loop back down to A and loop back up to S, we can get AB, and then we can choose lambda the next time around. So AB is also possible. So in the slides, you'll see all these solutions printed. I think going over verbally may help make sense of this, but I wrote out some explanations here. And the last thing is, what does this language represent? Well, we can have nothing, or we can have AB, or we can have AB, or AB, right? So the key is it's the pattern in parentheses, AB, close parentheses, star, 0 or more, AB, repeated, right? So these grammar rules can define a language that we can then express as a regular expression or draw as an automata. And so all this ties together. And ultimately, that's what grammars are for programming languages, is that you define a set of rules, and these allow you to define what possible sentences there are. So what is a legal line of Java? And so hopefully, we will eventually start to see by the end of this a transition from really basic symbols into what a real grammar looks like. We won't get really deep, and honestly, if you want to write a grammar for a language or understand a grammar for a language, it will take more time and effort, but you should at least be introduced to the idea here that every language is defined Every programming language is defined by a set of rules called a grammar, and this is generally how these rules work. So we'll dive into some more examples next time. Thanks for sticking along.